Over the last 40 years, I've developed and led fuels and combustion equipment safety programs for the largest manufacturers in the world. Today, I'm bringing you knowledge, insights, and best practices about fired equipment and natural gas safety. Over the next few minutes, you'll get the kind of practical, real-life explanations that I've become known for.
In 2018, 2 men perished at Evergy's Jeffries Energy Facility in St. Mary, Kansas. This is the largest power plant in the state of Kansas. The accident occurred when these men went in to investigate a steam leak and unfortunately were exposed to the escaping steam. Today, I'm interviewing award-winning engineer John Pushkar about the incident, and John will be providing some new ideas about how to minimize the risk of this happening at other facilities that use steam. John is a member of the NFPA 85 Boiler Combustion Hazards Code Committee and has spent his career advising industrial and large commercial clients about avoiding fires and explosions. John, can you give us an idea of what happened in this accident and how those that work in these kinds of facilities that use steam can better protect themselves?
So let me start with giving you some information about what was publicly available regarding what happened here. This is, again, a large power plant facility, the largest power plant in Kansas, 3 800 megawatt units. I believe it was 2,900 pounds steam or something close to that, superheated, of course, to run turbines. And there was a massive release of steam. The information available says that there was a problem with the safety relief valve. 2 gentlemen decided that they needed to investigate. These power plant facilities are very tall structures, many floors. Often there are elevators to ride to get up to the top. They decided to take an elevator up to investigate what was going on. It was clear there was a release of steam. It's my understanding when the elevator doors opened, they immediately became overcome with steam. They perished, unfortunately, very tragic. But hopefully there's something in all of this that we can learn which can be applied to your facility.
I'm guessing that there are steam leaks all the time at these kinds of facilities, and going to check on things is not out of the ordinary. So what kinds of things can people do to avoid these types of hazards?
You're correct. Lots of steam, lots of pipe, many opportunities for there to be steam releases. And frankly, that's why I'm not focusing on the root cause of pipes breaking or valves failing and steam being released. There's just too many places it can happen in these facilities. Instead, what I really want to focus on is where people are when these releases occur, how prepared they are, how much they've thought through the design of their facilities, and possibly places where people can and cannot be rescued, places where they can get to safety, places where maybe they can or cannot shut down the facilities, and possibly thoughts they need to be having, like, can I shut facilities off from a remote location in an orderly manner so I don't make things worse? These are some of the things I want to talk about in today's episode.
So if or when that does happen, and if there's a big steam release like a pipe breaking, aren't there automatic controls that take over? And don't people have time to get out of that situation?
Good insight, Layla. Yes, there are automatic controls. Unfortunately, they don't work as you might expect. In many cases, there are controls that seek to maintain a particular pressure level, either in a main set of steam piping called a header or within the boiler drum itself. So if you do have a catastrophic opening up of the system, a major pipe break, a safety relief valve going off, quite often, unless you've hit a high steam pressure limit, the boiler automatic controls say, my God, we're dropping pressure, we need to fire harder and make more steam, which in many cases can compound the problem. And the answer to your second question is it depends. It depends on where you are when the incident occurred. And that's a particular topic that I want to bring up that I believe has the potential to save lives moving forward. I believe that just as throughout industry, everybody has heard of and knows about confined spaces, and confined spaces are generally categorized as places where there may be a shortage of oxygen or the ability for someone to rescue you if there were a problem. Like, for example, in the firebox of a boiler, or in a large pressure vessel where someone needed to go inside and make repairs. I believe that it's time to rethink how boiler facilities and steam plants are laid out and how we think about the various spaces within them. Today, I want to introduce a new concept to everyone out there. I believe that we should have something like, and I'm going to give it a name, a steam leak at-risk space. And I wish there was a cool acronym for that. Maybe somebody can come up with one. But just as there are confined spaces in industry, I think it's time we re-examine how we've configured our boiler house facilities and some of the areas surrounding them. For example, steam tunnels. If there were to be a large release in a steam tunnel with a couple of people, maybe in the middle of that tunnel, would they have time to get out? Could you rescue them? What about the top floors of many boiler house facilities, where there are multiple boilers and there's catwalks or walkways, and if a safety relief valve went off and there were a problem with the discharge, it would certainly likely flood the entire area where people are. Should this also be a steam leak at-risk area? I believe so. And I think that we could reapportion and describe to people these particular areas in our facilities, and I think that we could make new rules for access, for monitoring people in these facilities, maybe even cordoning them off and restricting these areas to particular people who have certain PPE, and maybe people that are being monitored so there's some ability to rescue them. I'll give you an example of how bad things can be with steam. In 1990, the U.S. Navy ship Iwo Jima had a valve that had just been serviced come apart. There was 600 pound pressure steam that was released into the boiler room area of the ship. There were 10 sailors who couldn't make it out. Because you see, once steam starts to release, it's under pressure, it takes up volume very quickly. The things that happen include severe skin burns. If you inhale it, it burns your lungs, and it also displaces oxygen. So there's 3 ways to get hurt. In some cases, it's better that you be in a smoke-filled room. Fire departments know how to deal with that. They have self-contained breathing apparatus. They can crawl along the floor and get to you. But if you're in the middle of a steam cloud and there's high pressure, hot steam shooting out at you, or it's in between you and the fire department, I'm not so sure they'd have a way to get to you. I've had control room operators tell me that a tube ruptured and within seconds they were on their hands and knees hoping they were crawling in the right direction. I've learned from a boiler inspector that used to work at my place what a dive out is. He said that he's had to dive out thinking that it's better to break some bones than to be cooked by a steam release. I want you to go back and rethink how your control room is configured. Does it have enough escape routes? Is it protected enough from what can actually happen close to you? I want to point out an example of what happened in a control room of a drilling rig. The prior trust well explosion. You can find this on www.csb.gov, the U.S. Chemical Safety Board website. There, at a massive explosion at a well site, folks could not get out of the driller cabin, which is kind of the control room for a drilling rig. I think if you really go back and think through some spaces you have at your boiler plant, you might also agree there are things you might want to now redo. There are areas you might want to designate. At least that's what I hope makes sense to come out of this for you. At the very least, I'd like you to do some mock drills, create some procedures, think through what actually you would do if there were to be a massive steam release, if the place were to suddenly start fogging up, if you had to abandon ship and get out of the place, could you do an orderly shutdown from outside? How exactly would you do this? And don't just talk about it, do some walkthrough drills. It's building this kind of information into reflexes, into the subconscious, into being something that you don't have to think about, that's truly useful.
Wow, I had no idea there could be so much to what at first seemed like a simple issue. John, thank you so much for taking the time to address this topic and to provide some insights that could help.
Happy to do it. The things I've talked about today really are going to require a team effort and a collaboration of operators, maintenance people, and people that manage these kinds of facilities. And if you get into these kinds of efforts and you want some outside assistance, you want some insight from someone who's been around to over 300 facilities in over a dozen countries over the past 40 years, I'm there to help. Could be a phone consult, could be a remote meeting. I could come to your site. I can be reached at jpushkar, Jpuskar, at prescientts.com or on my cell at 216-213-6201. Again, Layla, thank you for helping me to make a difference. Hi, it's John Pushkar. I hope you found this episode useful. If you'd like to know about more ways that I can help, you can check out my website at www.prescientts.com. There you'll find information about the Prescient Technical Services Online School, my book, Fuels and Combustion System Safety, What You Don't Know Can Kill You, and also about some of the consulting projects that I've been providing to clients for the past 40 years. Things like implementing inspection and testing programs on a corporate enterprise-wide level, things like reviewing and commenting on capital equipment purchases that involve combustion equipment, and even being a legal expert if things go really wrong. Once again, thank you for attending, and remember, be safe out there. The life you save, it just might be yours.